Hi everyone, I'm Tim Kington and this is Coding is for the Birds. Daisy and I are working our way through a Java virtual machine, and today we're going to take a look at the switch statement. All right, let's try a switch statement out here. Guess we can get rid of all of this. Maybe not. Let's do a simple switch. So case 0, we'll say y equals 1, x 1, we'll say z equals 1, and default, we'll say y equals 2. Do that, we can take a look at our dump, and we'll see we've got a new thing happening here. So we have this table switch opcode, and then it has cases for each of our cases in the switch statement. So this is actually a pretty complicated opcode. It has a bunch of data in it. If we take a look at table switch here, so it's going to have the table switch opcode, then it has some padding, which is going to make sure that this next bit is aligned on a 4-byte offset. So this is for like optimization of your CPU executing the command, I guess. So we need to eat 0 to 3 bytes here. Then we have a 4-byte integer that is our default value, or our offset to the default branch. Is that right? We have an int that's default, we have an int that's low and an int that's high. And then in the switch, we're going to have basically cases for each of the values from low to high. And then we're going to have a bunch of jump offsets. And the jump offsets are, these are going to be 32-bit offsets as well. Okay, so we're going to have default, low, and high, and then we have a bunch of 32-bit offsets that are the jump offsets for each value. Low and high are telling us the range of the switch. So right now our low is probably 0 and our high is 1. But we can mess around with that some. All right, so we should probably change that just to get our logic right. So maybe we'll do like case 2 and case 3, just to make it a little less simple, so that we get our test cases right. Now if I dump it, we see our table switch ranges from 2 to 3. So these are low and high. And then here are our jump offsets for 2, 3, and default. And we need to be able to reconstruct that. All right, what is this opcode? AA. I think as we go along, some of these Oneoff opcodes are going to get interesting. And we're going to have much more complicated code to build them. So here, well, I guess we can parse it here, but we might want a function for this. I think we'll have a function for this one. Okay, so we've already read the switch opcode. We are going to need to read the pad. So we need to read pad bytes until the offset, the index is divisible by 4. So we'll say while that's not 0, so index plus plus. I guess we could do this a little bit more efficiently. It's fine. Okay, now we need to read the default value. So we're going to say read long or read int, right? We want a value or a function like this that's going to read an int. I don't know. What are we going to call these? B3, B2, B1, B0, I guess. And now we're going to take 3 left shift to 24 bits, B2 goes 16, B1 is left shift to 8, and then B0 is not shifted at all. What's wrong with this? Oh, yeah. So then here we're going to say default is going to be our read int. And then we need to do this a few more times. We're going to read low and high. And then we need to read our jump offsets, which is going to be an array. So we'll say new int array, and the number will be high minus low plus 1. And then we're going to read it. So all right, so this should give us all the stuff that we need. I guess I can't use default as a variable name. And then here we're going to create a switch op, and we'll give it this stuff. So we are going to need our code index, right? Code offset. So we'll have to pass that in. Or we could subtract 1 from index at the beginning. I don't want to do that. So this is going to take code offset, default offset, low and high, and the offsets. So that's fine. This is going to extend operation. We're going to have an int that's default offset. We're going to have low, high. I guess we'll call this dest offsets. And then we're going to want a constructor that populates all of this stuff. And we need our execute. And then execute is going to say case file is stack.pop. And say if case file is less than low or greater than high. And we use the default offset. So we're going to return that. Otherwise, we're going to look in our jump table and return dest offsets. So case val minus low. I think that's going to work. And what's wrong here? We haven't saved switch up yet. Okay, and then back here we needed to pass code offset. This might run. We got 0, 1, 2, 0. So what should have happened is x is 1, we go to case default set y to 2. So x is 1 and y is 2. And that looks like that's what happened. Now if we change x to 2, we should get a different case. This time y will be 1. X is 2 and y is 1. That looks right. And if we set it to 3, then z will get set instead. Okay, so it looks like this basically works. Okay, so let's add some tests for this. Let's see. We're not going to have a loop here. How are we going to test this? Well, we can write code that's something like the code we had here. It can be a little simpler. We can directly push a case and call a switch and see that it goes to the right place. So, in fact, our switch table could have garbage in it except for the case that we want to use. All right, so let's sort of build our switch. So it's going to be 0xAA, which is a switch. And then we're going to have some 0 padding. I guess we're going to need a byte here that pushes some value. So something like iconst1. And then we'll have a switch. And now since this is at offset 2, we need 2 bytes of 0 padding. And then we need our numbers for default, low, and high. So we're not going to use our default case right now. So let's make this huge so that it'll explode if it actually is used. Oh, these need to be byte, don't they? Oh. Fine, we'll just make this 1. That's big enough that we would go well outside of this method. Okay, low. For this case, we'll start with, I guess just like we did in the code. We can put low at 2 and high at 3. That's fine. And now we need a jump table with 2 entries in it. Case 2, case 3. And then we're going to need some code. So the first chunk of code will be our case 2. And I guess it should put maybe a 2 into our local variable. That would be a reasonable thing to do, right? So we'll do an iconst2 to show we hit case 2. And then we'll do an iStore. Zero, that's fine. And then we need a goto, don't we? So a goto is A7. And then we need a destination. We'll set this to 0 for now. So where should we jump to here? So if we're really not going to have real cases, default was broken. We'll make case 3 broken, I guess, also, if we're going to use case 2. So this should be an iconst2. And then we have our thing here. We're really just going to jump 3 ahead, I guess. We don't really need to jump at all because the rest of our code is the right place. So we can do a goto and then just go to the next instruction, which is our return. Okay, so 2, there's our switch. Now our jump for case 2, we got to figure out the number here. So from the switch, we're going to, let's see, we've got 20 here, plus 2, 22, plus the switch that we have to skip. So I think 23. So that's a 1-7 hex, maybe? Yeah, let's see if that works. So mostly we're interested in whether this explodes or not. That's most of the failure cases here, this logic just blowing up. But if it works correctly, there should be a 2 in the first local. It's quite likely that I counted wrong. Oh yeah, this should be 1. We got to the end of it. Wow, it actually passed. Okay, so I guess that worked. Now, we can do this a few times. Maybe we should actually build out the rest of this logic. So we could have a case for each of the branches. And we could run it in a loop. Sure, we'll do it that way. Okay, so we're going to say, this is case 2. We're going to use a 2. We'll figure out that jump in a minute. This is case 3. This needs to be an icons 3. And then this is the default case. And we'll do an icons 1. You know, we didn't really even need that goto before at all. Okay, so this one we do need. We need a goto, and it's going to jump 3, 4, 7, 8, 9, 12, I think. So this is going C. And then this goto needs to jump over 3, 4, 8, I guess. We'll find out. We don't need this one at all. Oh yeah, and I didn't need to jump 8. If I jump 3, it's here, so I want 4, 5. And this is wrong too now. So 3, 4, 8, 9, 10, 11. So this is A, I think. I guess we're going to find out when we test it. So I wrote this in a way that we can run it with values 1 through 3. And we should get that in our local variable for each one. This is going to be val. I'm a lot less confident that this one is going to pass. Okay. How far did we get is the question. I guess I need to put a breakpoint in there. Oops. All right. So let's, I guess this isn't where I want it. I want it right here. All right, local vars, the first time through has a 2 in it, which is wrong. Our expected locals is 1. Okay, so what was wrong with that first case? Yes, the problem is this. We're supposed to be pushing val on the stack. So this should be a 3 plus val. And then we need to turn that into a byte. Yeah, I forgot to vary the code. Okay, that is one thing that was wrong at least. Okay, and I got a bad branch at some point. Okay, let's try putting a breakpoint in here and just see what we got for our data. That's one thing that could be wrong. Okay, code offset. Default offset is broken. Low and high are 2 and 3, which is correct. We did not fix our default offset in the jump table. So low and high, these cases, yeah, I didn't fill in these either. So our case 2 here is probably right because it jumps to here. So that's 17 hex. So if this is 17, then we have 18, 19, 1A, 1B, 1C. So this I think should be 1C. And then this is 1D, E, F, 20, 21 is probably our default offset. These need to be zeros. Okay. Okay, so now we come in with reasonable looking offsets at least. We ran the first time and we got a 1. Second time we got a 2. Third time we got a 3. All right, so it looks like this test did work. I can't believe I counted all of those jumps correctly. That's pretty lucky, I guess. Well, now we can handle switch statements. Tune in next time when we will take a look at some more math operations. Thanks for watching. Don't forget to like and subscribe.